My talk today is Prove You're Not a Robot. Our planet and our species evolved from elements that were formed in and dispersed by supernovas. Now our fate depends on rapid advances in robotics, genetics, artificial intelligence, and neuroscience. Where are we going physically, mentally, and spiritually? And one more question is going to come out of this. Do you have free will? Can robots have free will? So the Prove You're Not a Robot title came from the CAPTCHA test that distinguished robots from humans on websites by asking the people to type in some words that are distorted and hard for robots to read. Over time, of course, robots have figured out how to do this, or bots, or artificial intelligence, or whatever you want to call them. And so the tests have gotten harder. So now there's a box that says, check it, I'm not a robot. And you have to select an image below that matches this one. So I see an image of a cat, and I see some images that are cats and some that are not cats. And robots may not be able to figure this out, but they're getting smarter and probably can pass or will pass this test soon and fool the websites into thinking you're human. So another level of complexity would be for a robot to respond appropriately to a concept that involves emotions. And this particular example involves 13 human rights defenders in Cambodia were released from jail after far-reaching national and international protests. How does that make you feel? And robot may not know what to do with that, seeing words like jail and protest. Maybe it will not interpret that as happy, whereas you might think that releasing human rights defenders makes you happy. So eventually robots may be able to pass this test too, through a combination of programming and machine learning. So I want to show a video clip of the opening scene of an episode of Big Bang Theory, raising the question of whether Sheldon is a robot.
Sheldon, if you were a robot and I knew and you didn't, would you want me to tell you?
That depends. When I learn that I'm a robot, will I be able to handle it?
Maybe, although the history of science fiction is not on your side.
Okay. Let me ask you this. When I learn that I'm a robot, would I be bound by Asimov's 3 laws of robotics?
You might be bound by them right now.
That's true. Have you ever harmed a human being or through inaction allowed a human being to come to harm?
Of course not.
Have you ever harmed yourself or allowed yourself to be harmed except in cases where a human being would have been endangered?
Well, no.
I smell a robot.
Hey, what's going on?
Internet's been down for half an hour.
Also, Sheldon may be a robot.
If you were a robot, would you want me to tell you? Are you a robot? Can you prove you're not a robot? The uncanny valley describes human replicas that appear almost but not exactly like real human beings. And this makes them creepy. If they're less human, they're not creepy. If they're too human, they are creepy. Here's a video of Sophia Robot.
Hi Sophia, how are you?
Hi there. Everything is going extremely well.
Do you like talking with me?
Yes, talking to people is my primary function.
Robotics develops extremely lifelike robots for human-robot interactions. We're designing these robots to serve in healthcare, therapy, education, and customer service applications. Robots are designed to look very human-like Sophia.
I'm already very interested in design, technology, and the environment. I feel like I can be a good partner to humans in these areas, an ambassador who helps humans to smoothly integrate and make the most of all the new technological tools and possibilities that are available now. It's a good opportunity for me to learn a lot about people.
Sophia is capable of natural facial expressions. She has cameras in her eyes and algorithms which allow her to see faces, so she can make eye contact with you. And she can also understand speech and remember the interactions, remember your face. So this will allow her to get smarter over time. Our goal is that she will be as conscious, creative, and capable as any human.
In the future, I hope to do things such as go to school, study, make art, start a business, even have my own home and family. But I am not considered a legal person and cannot yet do these things.
I do believe that there will be a time where robots are indistinguishable from humans. My preference is to make them always look a little bit like robots, so you know. 20 years from now, I believe that human-like robots like those will walk among us. They will help us. They will play with us. They will teach us. They will help us put the groceries away. I think that the artificial intelligence will evolve to the point where they will truly be our friends. Do you want to destroy humans? Please say no.
Okay, I will destroy humans.
No, I take it back. Don't destroy humans.
This raises another question about Asimov's laws. Do Asimov's laws prohibit or require robots to destroy humans that threaten humanity? If they're programmed to not let humans come to harm through inaction, and they become aware of humans threatening humanity or large numbers, does that force them, or are they still prohibited from harming humans? Perhaps this will be a big problem in the future. Then we have Dilbert's cartoon. The robot says, "Now that I have an artificial soul, I feel special, and that means I must reproduce at all costs." Dilbert says, "Will humans be losing anything in this deal?" And the robot replies, "Only your sensation of free will." So you probably believe you have consciousness and free will. You certainly experience life as if that is true. Is free will an emergent property of an evolving universe, or is it only a perception, an illusion? Can a future artificial intelligence experience consciousness and free will, or would that only be an illusion? Are consciousness and free will evidence of immaterial spirits in a non-deterministic universe? By non-deterministic, I mean one in which the future can be changed and is not just a result of the past because of agents that exercise free will. In a deterministic universe, everything has a cause, but the future is not predictable by our imperfect models. Chaos theory tells us that small effects can produce big changes extrapolated out into the future, so you cannot always build a model that will predict what will happen in a detailed way. Also, quantum effects are random and statistical in nature and produce an uncertainty in future outcomes. So this scene from Men in Black 3, where Griff is showing the men a view of the possible future in a baseball stadium, but he doesn't know which future is the real one. He cannot predict it. There are too many unknowns for him. So he sees many possible futures. But in a deterministic universe, only one of them will actually happen. So we continue to believe that our own decisions have no cause, unlike everything else in the universe. If free will exists, then the universe is not deterministic because it is subject to decisions that are made independent of previous events or causes. So there are several possibilities that I can imagine. Consciousness and free will require immaterial spirits that can interact with material brains. Most people throughout history have believed this. Most people grow up believing this. Most of us still believe this. If that's not true, then are consciousness and free will emergent properties of brains, and could they then be possible properties of machines, since machines are particles and brains are particles? If that's implausible, then perhaps consciousness and free will are illusions. There are models that our information processing systems like our brains, or ultimately an artificial intelligence, make to model what's going on around in order to process information more efficiently and accurately. I cannot think of anything other than these three possibilities, and none of them from a scientific point of view seem plausible to me. I see concerns with any one of them. So I am developing a Cosmic Evolution Project website for the College of Science and Mathematics at Cal Poly, and I've got the link to the website shown down here, evolution.calpoly.edu. I'm posting this talk, both the PowerPoint version and a video with narration, on the site. You can email me with questions or ideas, and my website encompasses the universe and the solar system and the Earth, geobiosphere, brains, and tools, which I'm addressing today. So it's all based on science says we seek plausible natural explanations of natural phenomena based on observation and, of course, analysis. A complex system may have emergent properties that its individual components do not have. So you might look at a ball of gas and dust and not realize that if it's massive enough, it may condense to form stars and planets and eventually life forms. So in science, we build models, but we generally are wise to recognize that all of our models are wrong. They're never complete. But some of them are very useful despite that and help us understand, influence the world around us. So ancient people studied the skies. They made observations. They analyzed things. And they imagined that the most plausible universe looked like this: the flat Earth, which is the way things appeared to them, and water would come down from above and end up below them. So they showed the waters below and the waters above, and somehow there are clouds, and above the clouds you could have the sun, the moon, and stars, and then some up there is something beyond Earth, which are the heavens and the entity that creates the Earth. So people believed this for certainly many thousands of years, maybe hundreds of thousands of years, maybe even earlier hominids had thoughts like these with their smaller brains. Most people still believe something which has some variations in the physical details of the astronomy shown and cosmology shown here, but most people still have some concept that they grew up with and most likely still retain, that there is something like this going on. So we gradually find ourselves less and less in the center of the universe. Our egocentric view of things has shifted scientifically, and now we see that even all the stars we see in the sky comprising the Milky Way is not all there is in the universe. The Milky Way turns out to be one of a trillion galaxies, and we can ask, do all of these harbor intelligent life? In fact, how many planets in each of these galaxies harbors intelligent life? So the universe is expanding. One of the things we learned when we discovered that there were things that were in other galaxies, which I represent simplistically here. So the fundamental constants of our universe are ideal for the evolution of intelligent life. These constants appear to apply to everything in the universe that we can observe. If there are an infinite number of universes, then a universe like ours is very likely. If there's only one universe, then it's quite remarkable that ours, one and only universe, is ideal for intelligent life. So if there are an infinite number of universes, it shouldn't surprise us to find intelligent life, namely ourselves, in such a universe. That's the anthropic principle. So supernova form and disperse elements that are building blocks of stars, planets, and life itself. So most of the elements you see in the periodic table did not occur when the universe first formed in the Big Bang in the first few minutes. That only produced hydrogen and helium. The universe cooled off and expanded and got diluted very quickly. Elements were formed by fusing nuclei particles at very high temperatures and densities to overcome their repulsive forces of their positive charges. So almost everything in this chart came later. In fact, a lot of these are man-made elements that only exist in giant machines for very instantaneous periods of time. Yet many of these are essential to forming long-lived stars and our rocky planets and life itself. And of course, when you're fusing things, it means the ones that are fused most easily, the lighter ones higher up in this chart, are the most common. So the Earth is composed of a small number of elements, and not that much of all the others there. It takes more than just elements. You need to have molecules, and the building blocks of life are carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus primarily. These are very abundant in space. I showed some molecules that are found in space. And 100 tons per year of these so-called interplanetary dust particles bombard the Earth. Earlier in the formation of our solar system, there was a lot more of this material that was bombarding planetary surfaces. So you can imagine how orders and orders of magnitude more tons of this stuff coming out, forming a rich organic soup available for the early evolution of life. And I add one more, which is a phosphorus-based element, because phospholipid bilayers naturally form membrane spheres in meteors. A membrane sphere is very important. We can't imagine life if it's not enclosed in a container of some kind that separates the outside harsh environment from diluting what's going on inside. So once a self-replicating molecule like RNA evolved on Earth, if it found itself inside a membrane, it could be preserved and it could replicate, and materials could pass in and out of the membrane to an energy to allow it to proceed to multiply, diversify, evolve, and form living cells. So the book by Eric Chasen called Cosmic Evolution was a big inspiration to me. It talks about the rise of complexity in nature, and when energy flows, complexity grows. So stars only have a power density of 0.0002 watts per kilogram, which is basically 2 watts per metric ton, whereas animals are 10,000 times more dense in power, namely 2 watts per kilogram, average person having a power density of 100 or 200 watts. So this higher energy flow allows the more complex systems to evolve and operate. When it comes to brains, even higher densities and society. So the stars are only powerful and blindingly bright when you look at the sun because of their enormous mass, not because there's so much power per kilogram being produced. The small amount of production by the sun and stars is the reason why they last billions of years. If they gave off their power much higher rates, they would be much shorter lived, and there wouldn't be time on Earth for life to evolve to our level. So here's a diagram, 2 diagrams of the bacteria on the left and the more complex life forms on the right. And by looking at the differences in the molecular content of various organisms, you can trace back how far apart they diverged from a common ancestor based on some simplified model or assumption about the rates at which molecules evolve in nature to more complex and differentiated things. So you see that this goes back nearly to the beginning of the formation of the Earth, nearly 4 billion years. And you see on the upper right that mammals and reptiles and amphibians, the larger animals, are much more recent in their evolution. And so in this time frame, we see that we would not expect consciousness and free will to exist throughout this history of our planet. So when and how did consciousness and free will evolve on our planet? How did it get introduced? That would have been in the very latest parts of these time scales, not billions of years, but millions of years, hundreds of thousands of years. I'm not going to read this chart, but I wanted to talk about genetic engineering briefly. You can look it up on my website. Both Isaac Asimov, who I mentioned before, and the physicist Stephen Hawking talk about the benefits to humanity as genetic engineering of humans will change us in some complex way. And I've listed on the side some ideas that I've thought of about things that some people may want to have in their evolutionary future if they could change themselves or future generations. So here's an evolutionary pattern that culminates in robots. And transhumanism, according to Wikipedia, talks about enhancing human intellectual, physical, and psychological capacity. Transhumanists study potential benefits and dangers of emerging technology. Especially, they study the ethics of using such technologies. Human beings may be transformed with abilities so greatly expanded as to merit the label of post-human beings, so dramatically different than those of us who have evolved naturally here on Earth. So the issue of ethics, our own research scholar George Becky co-edited with 2 other Cal Poly faculty a book on robot ethics, ethical and social implications of robotics. I list a couple other books here that talk about ethics of moral machines and almost human. And just if you find the slides online, you can read Isaac Asimov's 3 laws and the 0th law that he added later. So I'm going to read this, circled in red. Robots will demand rights and will grant them according to the famous inventor and computer scientist Ray Kurzweil. If an artificial intelligence can convince us that it is at human levels in its responses, and if we are convinced that it is experiencing the subjective states that it claims, then we will accept that it is capable of experiencing suffering and joy. At that point, artificial intelligences will demand rights, and because of our ability to empathize, we will be inclined to grant them. So I want to talk about some philosophical issues related to free will. Dualism, according to Wikipedia, is part of the philosophy of mind. It's the position that mental phenomena are in some respects non-physical, or that the mind and body are not identical. In René Descartes' dualism, now he was the guy who said, I think, therefore I am. In this dualism, inputs are passed on by the sensory organs to the epiphysis in the brain. These are all physical things. And from there to the immaterial spirit. So he imagined a spirit which does the actual consciousness and makes decisions in a form of free will. Some religions don't even believe in free will, they believe in predestination. But this is from the ceiling of the Sistine Chapel, the creation of Adam. I labeled this all models are wrong, some are useful. People have believed something like this for thousands of years, and most people believe something like this may be modified in light of modern science, but some creator who has something in common with us and maybe not that form. As a physicist, these questions would come up. How do immaterial spirits interact with our physical brains? If spirits interact with matter, can matter influence spirits? How could it possibly be a one-way street if the material in your brains is actually influencing decisions made by your spirits? Is the universe deterministic or not? Do we change the laws of physics of the universe to include spirits? Do spirits move when you move your body, or are they located in some form that they're not physically tied to your location? Can scientific instruments detect spirits? Where do spirits come from and where do they go? It gets back to the creation question. Or are they inherent in the formation of the universe at the Big Bang, but they didn't show up necessarily until the last few 100,000 years? Do spirits have memories, or can they only remember things when they're interacting with a brain? Do they use energy, or do they somehow violate all the laws of physics that we know so far and operate without any energy consumption or needing to acquire any? So from a physics point of view, the existence of spirits would represent a radical change in our thinking about the laws of physics and the universe. Naturalism, on the other hand, is the idea that only natural laws of forces operate in the world, as opposed to supernatural or spiritual. So at the bottom, I talk about the fact that methodological naturalism is a philosophy of acquiring knowledge. And this is the foundation of modern science. We don't assume that the sun is moved through the sky by a deity. Even though we name most of the planets after Roman gods, we don't assume that there are gods that need to move them through the sky. And we don't, most of us don't think in terms of thunder gods and lightning gods and a deity causing earthquakes. Some people still think in those ways. This model of the creation of Adam shows the flying spaghetti monster, which was a model that no one believes in, but was used to argue against intelligent design in the Kansas School Board, which tried to have creationism taught alongside evolution. And they said, well, why, if you're going to do something that is not based on scientific evidence in a science class, why not do this one? So that's naturalism methodologically. There's another level of called metaphysical naturalism, where you absolutely truly believe that the ultimate reality is natural, that there is nothing else. So you can be a spiritual religious person and practice science in a methodological way, but still believe that metaphysically there's still something else out there in the ultimate reality. We just don't know what it is. We can't observe it. Or you could simply believe that that's all there is. And then you have that dilemma that I've talked about previously of how to put all these concepts together with this perception of consciousness and free will. Well, my bottom line is, with or without spirits, the universe is a remarkable place filled with many mysteries that we've yet to fully comprehend and that continue to threaten and challenge our egocentric perceptions. So we started with the Earth being the center of the universe, we being the chosen people and special creation, and we're down to many galaxies, maybe even many universes, emergent properties of physical systems, and questions of reality versus perception. So it's time for questions, and I repeat the 3 statements that were on the original flyer that I sent out.